Hey, my name is Alexandra Evans, and I'm going to take you through the valence bond theory for the tellurium pentafluoride anion. So the first thing we need to do is create the Lewis dot structure, which I will do for you now. Now that we have our Lewis dot structure, we need to count the electron groups around the central atom in order to create our VSEPR diagram. So we have 1, 2, 3, 4, 5, and 6 with a lone pair, which means our VSEPR diagram is going to be an octahedral, which I'll draw for you now. Okay, now we have our VSEPR diagram. I do want to point out that all of these angles are going to be less than 90 degrees, and that's because this lone pair repulsion is greater. So, and also by looking at this structure, you can tell that when doing our box diagram, we should have an sp3d2. So I'll begin to do that now. Okay, so here is our box diagram for our anion beryllium pentafluoride. All box diagrams are based on the central atom, so we start with beryllium. Beryllium has 6 valence electrons, but because this is an anion, it's got 1 extra electron, so we need to indicate 7. 1, 2, 3, 4, 5, 6, 7. The next thing we need to do is to promote 2 of these. The reason why we promote 2 is because of the 5 fluorine that are bonded to beryllium. So we promoted 2, and in this case, or in all cases, you're adding energy in order to promote. And those get promoted to the 5d orbital. So everything circled here, all of this is going to be hybridized. And we're hybridizing, and our orbital will be sp3d2. Here, indicated in yellow, are the lone pairs, which I showed earlier in the Lewis dot structure. Every electron in green, it is coming from the beryllium. And then every electron in blue is coming from the fluorine. This is just showing the electrons in fluorine times 5. So this goes here, this electron goes here, this electron goes here, this electron goes here, and this one goes here. Like I said before, these are the lone pair, and then the rest of these are bonding pairs. This is beryllium in its excited state, and beryllium to fluoride when it's bonded. Now that we've completed our box diagram, the next step is to finally do the contour diagram, which I will show you next. Okay, so here's our contour diagram. As you can see, we have beryllium in the center. We should have 6 sp3d2 orbitals. These are the ones that we hybridized above. So here's 1, 2, 3, 4, 5, and 6. Bonded to the sp3d orbitals, we should have 5 2p orbitals, and those are the fluorines that are bonded. So we have 1, 2, 3, 4, and 5. Again, these in yellow are sp3d. The ones in green are 2p. Each bond is going to be a sigma bond. So this bond here is sigma, 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 sigma. And then, of course, we have our lone pair of electrons right here. This lone pair, again, has a stronger repulsion than these bonding pairs, which is why all of these angles are going to be less than 90. Essentially, this repulsion is pushing these back. And here I've just added 2 different versions of the 3D molecule. Here you can see the lone pair, and then the 5 fluorines. Same with this one. Here's our lone pair with 5 fluorines added. So that's it. Thanks for watching.